As you aware that we don't have any homework for today, so your next homework due is next Wednesday. There will be around 3 to 4 homework due on next week, so make sure you guys start working on your homework here. We will continue with chapter 7.2 here, and I think you guys kind of know it already that this coming up chapter is quite difficult. So I would highly suggest you guys to make sure to get help. One of them is come and talk to me if you need help. That is during my office hours after class. So if you have any questions with your homework or anything, please come and talk to me after class. This is super important. The next few helps that I will say that is to get help from the Math Resource Center or get it from the peer tutoring. So where do you find them is you go to the college website, you just search for tutor, then tutoring. So the math sense right here. So there are two of these things. So I recommend you to go for these two. But if you have any English or any writing that you need help, then writing center will be the place you go for. Okay. So schedule an appointment. Just click on here for the tutoring. It's free for you guys, and then you will get a free tutor here. The Math Resource Center, you can just click on the Math Resource Center. This is where you get help with Dale or with where I think there's another person do. I think Dale is the one. You can either drop in with no appointment or you do a individual Zoom that you need. Okay, so drop in Zoom no appointment. So make sure you know what time they are available, or you can go into the college for that. So this is the some of the help that you can get for free. So make sure you utilize this help. Okay. All right. So we start at question number 2 here. So we will continue with question 2 with this Pepsi can in this case. So I'm going to split my screen into 2 so I can get my Stack Crunch running on the background here. So this question number 2 in this case is asking us for to find what's the best point estimate. Question A for the population mean. So the best point estimate is the sample mean X bar, which is given to us by 0.8241 pounds. Okay. And then to find a critical value T alpha over 2, you required to use what we call in the Stack Crunch T calculator. So where you go to write in here in stat, you go under calculator and T. And the first thing they will ask you is to figure out what is the degree of freedom. So the degree of freedom in this case is going to be 35 because there are 36 cans of Pepsi N. So the degree of freedom is N minus 1, 35. And then you can use the alpha, which is 0.01 from the 99% confidence interval, and you divide this by 2. So that you will find out that this critical value for this case is going to be plus minus 2.724. Unfortunately, in the T calculator, you only get the negative since we are using the left hand symbol or the significant low side. So as we know that the high side will be exactly the same, but it's only positive. So that's why you do need to put the plus minus sign here. And last word is in your online homework, do not like plus minus symbol. You have to write this answer twice, one the positive and one with a negative. Question C, you have to find the margin of error. But before we continue with question C, let's do question D, where you find the confidence interval. I think on yesterday's video or yesterday's class, I mentioned about you do not need to follow the order A, B, C, D, E. You can actually switch them around. So when you find the margin of error, you actually need to find the confidence interval first, because the margin of error formula is the upper minus lower divided by 2. So we're still using the same formula that you have for the 7.1 and 7.2, which is to find the margin of error. you take the upper limit minus the lower limit divided by 2 here. So so let's find the confidence interval. So so let's do part D first. So in order for us to do part D in this case, you have to use that t-test, one sample, and this one is going to be with summary. Okay, so so when you do a population mean, this is where you will go a stat, t-stats, one sample, and you got an option to do either with data or with summary, because this question is giving us the summary statistics. So we're gonna go with summary, and then you have to enter your information there correctly, and you cannot round these numbers, because if you round the answer, the questions, the data information or the summary statistics given in the question, you get it wrong. So the mean in this case is 0.82401. The standard deviation is 0.00570. Sample size is 36, and you're gonna click down here for the confidence interval, and we are looking for the 99% confidence interval. So this will give us so this is what you get when you do the mean, the t-test. So this is the 99% confidence interval. You will find the sample mean, which is what we call as the best point of estimate. So I will tell you that if you forget about your best point of estimate, your StatCrunch will give it to you where you look for the sample mean. This is the 0.8241. That is the best point estimate. Again, we're not doing standard error. So the degree of freedom is 35, which we found out that by taking n-1. But the most important information that you see here is the lower and upper limit. So that means that the 99% confidence interval for this case will be given us by 0.822 till 0.827 grams. A pound, sorry, no, grams is a pound. So what does that mean here, class? That means that if you go and buy a Pepsi can and you weight it on a scale, how heavy is this Pepsi can? 99% of the cans will be around this weight, 0.822 to 0.827 pounds. So that means that this is for population, means that no matter where you buy it, you go to other state or other country and buy a can of Pepsi and you weigh it. I'm talking about regular Pepsi, not the diet or not the other flavored one. Then you will get this this weight for sure. Okay, and how confident we are 99% confident, means that you still have 1% that the can might be either lower or above that weight that we just found here. Okay, so that is what the confidence interval do, and that's how powerful it is, and that's why people are still using this, and this is really, really important. That's the reason why that people who do analysis in statistics usually do that. Okay. Next, we go back to part C, where the question wants us to find the margin of error. Again, the margin of error is where you take your upper limit minus your lower limit and then divided by 2. So your upper limit is 0.827 and minus your lower limit, which is 0.822. And then you divide this by 2. So again, calculators, parentheses 0.827 minus 0.822, and then you divide this by 2. So it's going to be around 0.003 pounds. Now, so this is I think I told you that the first test or in the midterm test, I'm kind of very pay attention close to your units, especially the few open-ended questions that you did. But in the finals, you're not worried. I mean, if you forget to put units or forget to circle the units here and put down units, do not worry about that. I will not take any points off, or I won't deduct any points due to units. I'm not that picky on the units now on the finals. I'm more picky on your how you find your numbers and your works in this case. So if you forget to put your units like pounds in this case, don't worry about that. Okay, I'm not taking any points off. So so that will be the margin of error in this case. And then in part E, they want you to write a statement to briefly interpret the confidence interval. So part E is to interpret your confidence interval, and we did some interpretation before. So we are 99% confident that the interval from 0.822 pounds to 0.827 pounds will capture the true value of the population mean. Forget we need the mean here. And now you put down the context of this, what is this 0.822 and the mean weight of Pepsi cans. Okay, so this is how we interpret the confidence interval here, which is very similar to what we did before when we interpret the one that I draw in the purple box here. So make sure you put this into your cheat sheet. So I recommend, I know it's another 3 more weeks for your test, for your finals. I would suggest you to start working on your cheat sheet in this case. So this is how we do question number 2 here. Does anyone have any question for me? All right. For question 3, you are going to refer to the data set number 1, which is called body data, and construct a 95% confidence interval for the population mean pulse rate. So we are doing only pulse rate, and you're going to do for females, and then after that you do the same thing for the males, and then you will compare the results. So this is the time, this is the question that asks us to have what we call as 2 confidence interval, and we want to compare it. Okay, so this is the time that you have 2 confidence interval and we compare it. So how do we do this 95% confidence interval? First, you have to get into data set number 1. So how do you get data set number 1 is go back to your StatCrunch originally in my stat lab. Go into the data set from your textbook here, and you go in the data set number 1, which is the body data. And we are only concentrate on the pulse rate, or in this case, your pulse. Okay. So what we do here is we go, because this is in this is the data. So we will go to stats, t-test, 1 sample. This time we're going to go with data. Okay, so we're going to go do that. So we will go to stat, t-stats, 1 sample with data, because the question already provides us the data here. And what we do is we will go pulse in this case. But and then you go check on the confidence interval, you do a 95%. Now, if you just do this, click on the pulse and do the 95% confidence interval here. And when you hit compute, this is not the correct pulse, correct confidence interval. The reason why I say this is not correct is because this is for all the people in this data set. All, I don't know how many of them, a lot of people. Okay, 300 actually, because the degree of freedom is 299. So there are 300 people here. But that means they did not break this into male and female. They just do all 300 male and female together. So how do we separate between male and female? It's very easy. So go back to option and add it. So go back to the same place we go, stat, test, and 1 sample with data. Yes, we still select pulse, but then you do group by. So what it mean by group by means they separate your confidence interval based on the group that you pick. And I select gender, where 1 is for the male and 0 is for the female, as you can tell by looking at here. So when you hit compute here, now you find out that the 95% confidence interval that you find here has 2, because it was break into 2 groups here. So the 0 is for the female, as you can tell that, and 1 is for the male. Okay, so let me show it to you where is it at. So we start again. So if you want to have 2 groups or more than 2 groups, so you go to stat, tstat 1 sample with data. You select the pause, and then right here, the group by, you select the gender. That means you separate this based on male and female, and you go to the perform the confidence interval of the 95% level, and you hit compute, and this time they will provide you both. So that means StatCrunch will automatically pick all the zeros and find what is the confidence interval, and pick all the ones, which is male and 0 is female, and find the CI confidence interval in this case. So for the 95% confidence interval for the female one, is gonna give us 72. I think that is the lowest, 72 to 76.09 BPM. So BPM is beats per minute, is the symbol, the unit for this case. Then for the male one, so the 95% confidence for the male one, the one right below it, 67.77 and 71.39 BPM. So this will be the 2 confidence interval using StatCrunch to find it. And I will tell you that if you are not using any technologies to find to do question 3 here, you roughly will take 1 hour to 2 hours to find these 2 numbers, the two confidence intervals here. So I will say that yes, that's the reason why if you use the formulas, if you use, oh my god, this data is 300 data set. Ooh, it's going to be a lot of so that's the reason why that I'm teaching you how to use computers, or what we call statistical software to find all these numbers. Okay. Now what we do here is we have to compare the results. So this is the comparing the result. So make sure you guys understand what do we do when you have to compare the results in this case. So what we do when we compare result is we figure out where is the female and where is the male one. Okay. So let's say we got 60, we got 70, and we got 80. So this is somewhere right here. And if you look at the female one is, I'm gonna use pink for female, or no, 72 to 76. So this is female. Okay. And the blue one for the male. The male one is between 67 and 71.39. This is male. Okay. So these are the confidence interval found in each one of found in StatCruncher. So now we need to compare this. Okay. Now, how do we compare 2 confidence interval right now? Later on, you will learn the correct way, but this is kind of like just to show it to you. In order for us to compare these 2 confidence interval in this case, you figure out if the confidence interval overlapping. Okay. So you can tell by drawing a picture like this, and you know that these 2 are not overlap, because if it's overlap, they will coincide or they will overlap, right? So since the confidence intervals do not overlap. Okay, so overlap means they kind of like to get screen together. And you can tell that the female is actually above than the male if you look at the chart. So we can say that the the female pulse rate. So this is how we compare. Is more than the male pulse rate. So when you guys do comparison, there are 3 comparison you can tell. Either female, example, this female pulse rate is more than male, or the male pulse rate is more than female. That means if you change your M and F backwards, then those are the male pulse rate is higher than the female. I'll put a note in here, okay, in rate. Note if the CI overlap, that means now those cases that if female more than male or male more than female only happens if you find out that the confidence interval do not overlap. But what happens if they overlap? Then they are equal. The pulse rate are equal, or sometimes use the word same or no difference. That means that if you find out that, let's say I give you the male one is over here now. So that means now what you do is that is an overlapping case because they overlap. So I don't care how much or how little they overlap. If they overlap, this is the comparison you have to write. So if the confidence interval overlap, then the pulse rate has to be equal, or in this case, they are same. Okay, so I want to point out to you guys that so this is, I just draw a little picture here. So so you guys will know what you mean by overlapping here. So you will get this is one, and then this is the other one. Okay, so this is what we call as an overlapping in this case. Okay, so overlapping cases. And the best way for you, if you guys are not familiar with this, I would recommend you to just draw a number line and then draw me the confidence interval for the male and the female one, and see what happens to these two. Okay, so that would be the best ways for me to show to you. Anyone have any questions here before we start with the last question? All right, so for the last question, listed below are the 15 randomly selected Los Angeles commute time. So this question wants you to construct a 90% confidence interval for the population mean. And then the question say, is a confidence interval a good estimate for the population mean? So how do we find this 90% confidence interval here is, first, you have to put this in var1, okay, or what in a variable in a column in StatCrunch. So that means that you have to open a new StatCrunch here, var1 here, and then you will enter this data in here. Now, if you have this in your homework, you just need to import that into StatCrunch. So you do not need to enter like what I just did here. But however, in the test, you do need to import this. You have to enter like what I just did in the StatCruncher, and make sure that you enter the data correctly, because one wrong number you enter, your whole your answer will be wrong. You just want to point out to you that. So okay, so this is the, and if you want, you can label your var1. I just put CT, which stands for commute time. So how do we find the 90% confidence interval in this case? We do the same as what we have there. We went to stat, t-test, one sample with data, because the question provides us a data set. So we will go to that data stat, t-stats, one sample with data. And we only got one here, CT, and we are going for the 90% confidence interval. So change the 95 to 90. And you just hit compute. So this is the 90% confidence interval here. So the 90% confidence interval is given us by 14.659, not 14, to 30.408. And I think the minutes is the units here. So this is how you find a 90% confidence interval for question number 4 here. So then the question is asking is the confidence interval a good estimate? Okay, so in order for us to figure out if this is a good estimate, I'm going to make this bigger so you guys can see it. This question actually asking for the requirement check. Okay, so if a question asking that if this is a good estimate, we have to check the requirements. So far, we haven't checked any requirements yet. So if you go to back, what are the requirements in this case? So the requirements is for first, it has to be a SRS, okay? And second, it has to be CLT. CLT means a population is normally distributed or your sample size is more than 30. And if you have a robust case, means your sample size is small, then you have to check these 3 other conditions to fulfill CLT: symmetrical, one mode, and no outliers. Okay, so we will see this in this example here. So the first requirement that we have for this case is SRS. And sometimes I don't know what happens. So first requirement is SRS, and in this case is check. The reason why this is check is because if you read the question, it has the word randomly selected. So that will be the SRS requirement here, which is good news. The second requirement we have is CLT. Unfortunately, CLT does not check. The reason why CLT does not check here is because one, it is less than 30, because it's sample size only 50. You have 15 numbers here. And two, is the population is not normally distributed. Why I say the population is not normally distributed is because the question did not mention anything saying that this comes from a normal distribution. So if you recall what we did in chapter 6, we find out that the temperature is normally distributed with the mean of this and the percentage of that. You see in chapter 6, all the questions has the word normally distributed. That means that the population is normally distributed, what you guys just did in the test, the midterm test. But unfortunately, if you look at this question 4, there is no mention anything about normally distributed. And I will tell you that you cannot assume that this is normally distributed. So that means that CLT here does not check here. So what we do here is we have to check the robust case. Because our n is small. Our sample size is small in this case. So we have to check the robust case here. What is the robust? And if this robust case good, then CLT was considered check in this case. Okay. So the first robust case is make sure that it is symmetrical. Second case is you have one mode. And third case in this case is it has symmetrical, one mode, and no outliers. Yes, these are the those can have an outlier. So we're gonna check this now. So I'm gonna minimize my little word here. So how do we check for symmetrical and outliers? We draw box plot. So the box plot will be used. So so hopefully you still remember how you draw your box plot from your midterm test here. So you go to graph, go to box plot, click the CT, which is the variable we're using. And again, don't forget to check these two options here to draw your box plot, and you hit compute. So this is the box plot in this case, okay? So what you notice is one, symmetrical. What is symmetrical means you cut this right in the middle, and you notice that the right and the left is somewhat symmetrical. Although I know there's no whiskers on the left side here. So, but don't forget the median is right in the middle of this box. So the right side and the left side of this, if you look at the length, is somewhat symmetrical. I'm saying somewhat, that means you do not need to be perfect, okay? So the good news is this one is checked. Okay, the symmetrical is checked. No outlier is also checked. The reason why there's no outlier here is because you don't see any dots in the far end point here. So, so good news here is that it's no outliers and it's symmetrical. So that's good news that we check on those two. Now we're going to figure out if you have one mode. So in order for you to figure out if they have one mode, you have to do the Control A. Remember the Control A that you guys also learned in chapter 3. So so what you do is you go to Stat, Summary Stats, and Column. Click on the CT. Control A on the statistics. And then drag all the way in. And you find out that this has also one mode. Because the mode here is 5. That means you have one mode in this case. Otherwise, if there is multiple modes or no modes, they will say in here either no or multiple modes. But one mode is what we are looking for. So in this case, that your robust case is good news because that the area of all these three conditions are checked. So that means that your CLT will fulfill. So now to answer this question, is this confidence interval a good estimate? The answer will be yes. The CI is a good estimate because it fulfills all the requirements. Okay, so this is so to answer this question, you have to check the requirements, and if you fulfill all of them, then it's a good estimate. Otherwise, okay. So this is how what we do with this requirement check here. Does anyone have any questions with the last question in this case? So this question 7.2 is due on next Wednesday. So you do have 4 homework due on next Wednesday. I think there are total around 10 homeworks left for the half part of the semester here. So 4 is this next week, and then 3 and then 3. So you got not a lot left. So 4, 3, 3. That's what we left for your homeworks here. So so this is the end of chapter 7. Chapter 7 is short, 2 sections, but there are quite a bit of work that you have to done in this case. Okay. So so far what we learned in chapter 7 is what we call as the confidence interval. So when you do your stack crunch, you always select, when you go to the t-stats, you always select the confidence interval, if you remember what we did here. So so what is this hypothesis testing that you see in this stack crunch here? That will be for chapter 8. Okay, so so that's the difference between chapter 7 chapter 8. One is called confidence interval and one is doing a hypothesis testing. Okay, so it's very clear that if they want confidence interval, they will ask for the confidence interval in the question. If they want you to do a hypothesis testing, they have to provide you a claim statement. Okay, so that's the reason why that when you do hypothesis testing, they will provide you a claim statement. They don't call you to find a confidence interval like what we did in the previous chapter here. So so we're going to start with chapter 8 here, doing hypothesis testing. So 8.1 is the basic, the steps, the how we do the hypothesis testing here. And then 8.2, so this is kind of like the steps that I have to teach you. And then when you do 8.2, oh, I forgot to do something here. Sorry, because I forgot to do the first question on. I'm gonna go back to the first question. I'm jumping ahead here because I forgot to do the first question here. So I am just totally forget about that. This first question is gonna be come up in your MCQ in your finals. Okay, so make sure you guys pay attention here. This is gonna be definitely come up in the MCQ in finals here. So you plan to construct a confidence interval for the population mean. Use a given data to determine whether the margin error should be used to find a critical value. So this question is asking us to find a critical value. Is the critical value we use is Z alpha over 2? Like this one. Is that Z alpha over 2? Is that going to be a T alpha over 2? Or is that going to be neither? So these are the three options that you have here. So and use a 95% confidence interval. So once a question stated using a 95% confidence interval, that means your alpha, that little fish, is going to be 0.05, which is the opposite of 95%, or in this case, 5% here. So here are the rules that you have to know. Okay. Now, it is first thing you need to know is make sure that CLT is fulfilled or not. I think CLT, you guys know, right? The population has to be normally distributed, or your N, so sample size has to be more than 30. So this is a CLT conditions that we have that we've been doing. So if you say yes, that means that CLT is fulfilled, then you will branch up. I'm going to start to draw a little bit of what we call as a little flow chart. And if you say no, now if you say no, then your answer in this case will be neither. Okay, so which is this one. So if you find out that if your central limit CLT is not fulfilled in this case, oh, my handwriting is so horrible. I just misspelled this neither word. Then if you're not fulfilling the CLT, then it is neither. Okay. Now, if you fulfill your CLT, then this will branch out into another branch. Then you figure out if sigma is known or unknown. Well, again, what is sigma is? Sigma in this case is what we call as the population standard deviation. Okay. So if the population standard deviation sigma is known to us, we will use Z alpha over 2. And in StatCrunch, we will use the normal calculator. Okay, so this is how we figure out. What happens if sigma is not known? If sigma is not known, we will use the T alpha over 2. And in StatCrunch, we will be using the T calculator. And make sure you know that the degree of freedom here is N minus 1. Okay. So this is how we do this kind of example. And as I mentioned, this question is coming out in your multiple choice question in your finals. Now, there are 4 questions here, but in your finals, you only get 1 of this. Okay. And again, the number is changed. So what do we do for this kind of question is to check if they fulfill CLT or not. Okay. If they fulfill CLT, then you figure out if sigma is known or not. So this is actually this little flow chart that I draw is actually the third formula you put in here. Okay, this will be the third formula that you will need to know. And I will fill it out later on after the class. So this is the third formula that we'll be using in there. So I'll put it in there after class to save some time. So let's read the question and see which one is which. So for question A, your n is small. So that is no good. Okay, when n is small, it's no good. However, your population is normally distributed. That is good news because for CLT, because this is CLT, you fill in here, due to your population is normally distributed. Okay, so CLT means one or the other. So although the sample size is small, and then so we've got the yes part here because this is a CLT, and now we have to figure out if sigma is known or sigma is not known. By looking at this question, sigma is not known to us. So sigma is not known to us, so we have to use the T alpha over 2. So for question A, it will be a T alpha over 2. Okay. Now we have to find this critical value in this case, the CV for T alpha over 2. So in order to find this critical value, you have to use StatCrunch using T calculator. So you go to Stat Calculator T, and it asks you for the degree of freedom, and the degree of freedom in this case is n minus 1, where n in this case is 9. So 9 minus 1 is 8. And then you put in the alpha. Don't forget our alpha in this case is 0.05. And you have to divide this by 2 to have 2 of them. Okay. And when you hit compute, so your answer in this case is not just negative. You have to have the positive because it has two-sided here. It's going to be 0.2306. So it's plus minus 0.2306 will be the answer for question A. Is anyone doing okay here? How we do question A here? Repeat again. Question B, you find out that the sample size is still small, which is no good. And moreover, the population is skewed, which is not normal. So that means that both of this does not fulfill CLT. That means that this is no CLT. And if there's no CLT, so for question B, your answer is neither. And the reason why that the answer is neither means neither Z alpha or T alpha because this is not CLT that's not fulfilled here. Okay. Right. Anyone? Questions? Third one is repeat. The sample size is still small. We need more than 30. However, your population is normally distributed. So that is good news for question C. That means CLT can be used here. So for this question, we found out that sigma is known. So if sigma is known, we have to use the Z alpha over 2 in this case. So for question C, your critical value here will be Z alpha over 2, where you do the plus minus here. And in StatCrunch, we will be using the normal calculator. So you go to Stat Calculator Norm. There you go. And the mean and standard is 0 and 1. And we still use the 0.05 over 2 because that is the critical, the alpha, the significant level that you given in the question over 2. And again, you have to do the plus minus here. And so your answer will be 1.96. Okay. So this is how we do question C. Anyone have any questions for me? And for the last question, question D, you find out that your N is big, 75. So that means that CLT will be used. I don't care about this population, since if your sample size is more than 30, that's good enough, which is 75 here. Then you figure out, is this alpha, is a sigma is known or not known? So you find out that this question is stated that your sigma is not known. So since sigma is not known, so for question D, we will be using T alpha over 2 again, because our sigma is not known here. So so you go to the T calculators that calculate the T again. Oh, not Poisson. Yeah. There you go. Then the degree of freedom in this case will become 74, because if you subtract 1 from 75, 74, and we still use the 0.05 over 2. So you find out that for this case, the critical value for question D in this case is around 1.99. 1.993. So this is how we do question 1 here. And as I mentioned, this is gonna come up in your test. Okay, this is definitely coming up in your finals, finals, as in the multiple choice question. And I'm not gonna give you 4 questions here. I only give you 1 of these 4 with the different numbers and different scenarios. Anyone have any question for me? All right, so we will try to do chapter 8 now. So we're going to do the hypothesis testing in this case. So backtrack to where I want to teach you guys. So 8.1 is the basic of hypothesis testing. What is 8.1 is doing is I'm showing you how to do the hypothesis testing as the first time. Hypothesis testing in this case actually consists of 7 steps. Yes. So do you notice that in chapter 8, you find out that you got 1 whole page to do 1 question on top, and then the whole thing blank. The reason why that you got the whole thing blank is because you have to do these 7 steps testing here. Okay. So in 8.1, I am showing you this all 7 steps here. So you guys can see what these 7 steps is. So in 8.1, your homework will be break into individual steps. That means the first step, second step, third step, and so on. And then when you start doing 8.2 and 8.3, we will combine all these 7 steps into 1 whole question or 1 whole procedure. Okay, and we call that hypothesis testing. Okay. So and then in 8.2, we perform the hypothesis testing in what we call as proportion. Okay, that means this has to be in categorical variables. And then in 8.3, you notice that it is in what we call as the mean, where this is for the quantitative variable. So this is what you will notice when we do this. And the reason why I have to teach 8.1 is because this is probably your first time doing a hypothesis testing. Some students get a little bit confused about this, but don't worry about that. Mostly this 8.1 is coming up in your multiple choice question, because in the multiple choice question for your finals, I cannot come out whole 7 steps in A, 7 steps, B, 7 steps, C, D, E, all 7 steps. It's going to be very difficult for you to figure out which is the correct answer here. So what do I do in the multiple choice question in the finals is I break them into individual steps in this case. So mostly 8.1 I have to teach you is because you will see them in your MCQ finals. Okay, so let's talk about what is a hypothesis, what kind of methods we use here. Now, when you do a hypothesis testing, there are 3 types of methods that you can use. Okay, so I don't have time to go through all these 3 methods, So we only concentrate on the p-value method. In this case, we will not use the critical value method, and we will not use the confidence interval value method. Okay, so that means that we only have p-value method in this case that we will be concentrate on. The reason why is because currently the new guideline says that we have to teach you using this method. The critical value method is taught where if you take this class like 5 to 10 years ago, or maybe 20 years ago, and the confidence interval method is used if you take the class 5, 10 years in the future. So this is back, this is present, this is past, and this is the future. Something like the Christmas story that whatever that story that you have. So what you do in this case class is if your kids are taking stats class, if you have kids and in the future, they probably will not do these two methods. They will use the confidence interval methods in this case. Okay, so you probably were teaching if you are taking this class and if you teach them, they will change from p-value to CI method to confidence interval methods. And I think it's gonna be around like 10 years from now. I'm expecting. So so don't worry about if these two are something. I think there are in the whole chapter 8 and chapter 9, the entire chapter 8 and 9, I think there are maybe 1 or 2 questions that ask you for the critical value method, only 1 or 2 questions. So just bite your tongue and go through it. And some of you will ask me that, David, is this going to come up in your finals? No, these 2 methods will not going to be come up in your finals. We will be only concentrate on the p-value methods. Okay. However, chapter 9, this is the one that I will bring it up. Chapter 9 is where you will see a combinations of confidence CI method and the p-value method. CI means confidence interval that you guys said in chapter 7. So in chapter 9, we will be using these 2 methods. You will see that chapter 8, no, but chapter 9, yes. Chapter 9, you will see these 2 methods. You will see that when we finish chapter 8. So what is, in statistics, what is a hypothesis? A hypothesis is a claim or a statement about the property for the population. So, so when you want to do a hypothesis testing, you always must have a claim statement, or sometimes we call it the thesis statement. That means you have to see if this statement is valid or invalid. And this statement is always about the population, not about the sample. So example about claim statement in this case will be like more than 15% in this class will get an A. So that will be more than 50% in the statistic class will get an A. So not this class, but this class is a sample. So that means that my claim statement is telling that, is that true that more than 15% of the students that take statistic class will earn an A? So that, so it belongs to a population, and that is a statement, and we have to go through this 7-step hypothesis to either we support this statement, more than 50% students get A, or we does not support this claim statement. So this is usually what the hypothesis testing do to us. Okay, and then a hypothesis testing, or what we call as test of significance, is a procedure of a test to claim the property of the population. So we have to perform a hypothesis testing to figure out if this claim statement is valid or invalid. And again, as I mentioned early on, the procedure is a 7-steps procedure. So it's a long 7-step procedure. So I will be going through this 7-step procedure right here. So please pay attention. But before I do the 7 steps here, I will take attendance. So go ahead and do your attendance here. So the first requirement, the first step to do a hypothesis test is requirement check. Now, when you do your online homework, they will skip this step. They will just saying that, oh yeah, we can skip. We'll just assume that the requirements are fulfilled or the requirements are checked. So you can skip it. So I will tell you that when you guys do the online homework, they will skip it. However, when you do my test, you cannot skip it. So I'm going to take it away so that you don't skip it. So, so how many requirement checks do we have? So depends on what kind of requirement check here. So I'm going to put down requirement check here. So if we are doing proportion, if you're doing a population proportion, the requirement check in this case, so for the requirement for population proportion in this case, the first one has to be SRS, simple random sample. The second one has to be binomial. And then the third one, the requirement check has to be at least five success and at least 5 failure. So this is the requirement check for population proportion here. And the requirement check for the population mean. So don't forget, we are doing 2, right? For the one is proportion, one is mean. The requirement check is, the first one is SRS. The second one is CLT. Guess what? We just did that already in our just now, that CLT, where CLT stands for the population is normally distributed, or your sample size is more than 30. And then don't forget the robust case. Remember the robust case we just mentioned here, okay? This is only happens when n is small, okay? Then you will check for symmetrical. You will check for one mode and no outliers. Okay, so these are the requirement check for this case, which is exactly the same requirement check for the confidence interval. Okay, so that's the reason why that if you know the requirements for the confidence interval for proportion, population proportion, and population mean, I will say that this is the same requirement check for hypothesis testing. So they are the same. So, and this, I will label them as the 4 formulas you need to remember. So in the new formula, you got the third one, right? Remember the third one I just did, and you will get the 4th one coming out. Okay, so I will write this all out, because I after class I'll write all this out, and then you can see it in the email. I will send it to you. So so that will be the 4th thing you need to put down as what you need to know, and that will be a lead. I will be, let's say it's gonna be the same. Oh, by the way, I forgot the binomial here. So if anyone still remember the 4 conditions of binomial, you need to know n. You need to know it has to be independent, 2 outcomes, and the probability has to be the same. I have no room here, so I am going to write a little bit underneath it. 2 outcomes, and probability has to be the same. Same probability for each term. Let's put it that way. So this is the binomial 4 conditions that you have. So these are the requirement check that we have. And so this is the first thing you have to do. First thing you do in the procedure for this is the requirement check here. Now, since this is your first statistic class, if your requirements did not met, or if a requirement met or did not met, you still have to continue the whole 7 steps. Since this is your first statistic class. However, if you took this is your your 10th or 8th or almost graduate at the graduate level, then you should know that by the time, if the requirement does not, one of these requirements does not check, you have to use another sampling methods in this case, or sampling distribution. So for me in this class, I just want to point out, if this does not met, requirement does not met, you still continue working on the next few steps. Okay. Second step, very important. So second step is to what we call as to state your hypothesis statements. Okay. So for the hypothesis statements, you got two types of hypothesis statements. We have null hypothesis H0 and the alternative hypothesis H1. Okay. Some textbook or some homework use HA. So we call this the null hypothesis H0 and alternative H1. Now, what is a null hypothesis statement? The null hypothesis H0 states the value of a population parameter equal, I should not do this. I should use the word equal to sum of the claim value. Sometimes we call the null hypothesis no change, no effects, no difference. That means that when you write the H0, the null hypothesis, the equal symbol has to be used. Okay. Why we use the equal symbols? Because null hypothesis is something like a placebo, or we call it a control hypothesis. So we make them become equal in this case. Okay. If you notice the example that I use here, the number next to the equal sign, the 0.5 or whatever number we use next to this, next to this number here, that is what we call as your claim value. Okay, so this little value that we have here is called as your claim value. And where is this claim value come from? Okay, so this is called a claim value. This claim value is come from the claim statement. Okay, so this come from the claim statement. Okay, so if you remember what we did last, the claim statement that I talked about early on, okay, that more than 15% taking my class, taking the statistic class, get an A. That 15% that I'm talking about is your claim value. Okay, so that 15 has always come in a claim statement and means in the question. So usually you will know what I will give some examples. You will see it. Okay, and then there are two types of population that we'll be doing here. One is the population proportion P, and then one is a population mean mu in this case. Okay, I don't know what happens here. Something happens. Sometimes I don't like teaching it using this because it kind of have its own little mind. So so when you guys see this, so P it stands for population proportion, mu it stands for population mean. So in this case, that in 8.2 you will be using P, and 8.3 you'll be using mu, because one we're doing mean and one is doing proportion, the other one is doing mean. Okay, so that is what we call as the null hypothesis H0. Now, what is the alternative hypothesis H1 means? Is where the statement of the population parameter has a value that's somewhat different from the null hypothesis. So in this case, when you have what we call as an alternative hypothesis, we do not use the equal to symbol. So the H1 or the alternative hypothesis, the symbol that we use here is either less than, greater than, or not equal to. So make sure you guys know which symbol is which, because if you give me the wrong symbol, if you give me this is a less than symbol, but you give me greater than symbol, then you get it wrong. Okay, and you notice that when you have this symbol, this number next to it is also what we call as the claim statement or claim value, which is in the claim statement. And you notice that when you write your null and your alternative hypothesis, your claim statement has to be exactly the claim value has to be exactly the same. So if you use 0.5 here, you also have to use 0.5. So this two has to be exactly the same. Okay. Same number. Okay, so if I found out that if this is not the same number, you notice that something is going to be wrong. Okay, And then again, we will be doing two types of proportion here. Two types of population here. One is a proportion and one is the mean. Okay, so just want to point out to you so you guys know what to do here. So make sure you guys know this kind of statement here. So this is your second step. And then because we have three inequalities that we use here, less than, greater than, not equal to, then we will have to break this test into three types of tests. Either this is a right side test or a right tail test. This is a left tail test or a two tail test. So what is a right side or right tail test? A right tail test, if you have a normal curve, the area that you shade is only shading on the right tail. Now, if you remember last time when you do the significantly high, significantly low, so or both, so when you have a right side, you only concentrate on the significantly high area. So this is a right tail test and is only used for when your alternative hypothesis has the greater than symbol. Okay, so this will be the right tail test that we have. For the left tail test, you kind of know what it is. Your shading area will be on the left side. So this is for the less than symbol. And for the two-tail test, a two-tail test is where your shading is on both. That means your significant is on both low and end. This two-tail test is used when you have the not equal symbol. Okay. So how do we know, are we using less than, greater than, or not equal to symbol? So how do we know which one do we use in this case? It will be stated in the claim statement. So you only pick one of this inequality here. An example that I use is, if you remember what I just say in my claim statement example that I did, I say more than 15% will earn an A, right? We'll get an A in the class. So the word more than means is greater than. So this means that your test will be a right tail test because the word more than. So this is a right tail test. Okay. So this is kind of an example that I use. And if I say the people who get A in this statistic class is equal to 15% who get A. So if you have equal to, then your test is a two-tailed test. That means that when you do, if your claim has a word equal to, then you will be using this two-tailed test. That means you're going for equal with not equal. Okay. And then less than will be the left tail test in this case. So make sure you guys know what kind of tests we are doing here. And this is very important. Anyone have any questions with this left, right, or two-tail test? All right. So let's take a look at the examples. So the first two examples is what you will see in StatCrunch here. In your homework is where you do your hypothesis. This is how you write your hypothesis. Now, usually when I want you to write your hypothesis, they always give you a claim statement, the one that I asked you, like fewer than, more than, or equal to 15%. So what I always tell my students is, if every time they give you a claim statement, please highlight that. If you don't have a highlighter, make sure you underline, circle it, because that claim statement is very important, and that is where we want to test or to do to figure out if the claim is valid or not. So so this question 1 says that the claim is fewer than 95% of adults have a cell phone. So that means this claim statement is telling us that is it less than 95% of the adults now have a cell phone. So so this is a claim statement that we have. So, and then the question stated continuing saying that in a pool of 2,000, 1,128 adults, 87 say they have a cell phone. This result that they got in the pool is actually useless. So do not look at this information if you want to write the statement. So these statements that you have here, you do not need to use this. Okay, you only need to use this if the question wants you to perform the whole 7 steps. But we are only doing step number 2 to write the statement. So first, the question is asking us to express this claim. This is the claim in the what we call as express the claim in symbolic form. So you have to write this claim in symbolic form first. So the first time I always tell my student is, what is the word fewer means? Is that less than, greater than, or not equals to? So which one is fewer? Anyone? So that will be less than. And then the 95%, that is your claim value. And this claim value will be right next to the inequality. So you have to change this into decimals, 0.95. So this is how you write this question in symbolic form. Okay. And now the question asks us to identify the null and the alternative hypothesis. So the question wants us to figure out what is the null and the alternative. So the null hypothesis is shortcut to become H0. This is the null. And the alternative hypothesis is shortcut to become H1. Now, the null hypothesis, if you remember, always use the equal to symbol. And you have to pick, are we doing P, which is proportion, or are we doing mu, mean, okay, population mean? So how do we know, are we picking P or are we picking mu? You look at the question. Since the question, the claim value is given to us in percentage, we are using the P. P stands for proportion or percentage or probability. So that's why, so the claim value is in percent. So that's the reason why that we will use P in this case. And for the null hypothesis, we will use equal. And the claim value that we use here, 95%, change it to decimals because it's proportion, is 0.95. So this is how you write the null hypothesis in this case. That's the null hypothesis, H0. And now we're going to write the alternative. The alternative hypothesis is based on less than, greater than, not equals to. But since the claim statement says it's fewer, so you just take whatever you read in the claim statement and plug it back in. So it's less than 0.95. So this H1, or we call that as an alternative hypothesis, is given us by P less than 0.95. So again, as I mentioned, the claim value has to be exactly the same. And the null hypothesis has to have the word equal to. The alternative depends on the claim statements. And then the P is used because the claim value has percentages. So this is how you write the null and the alternative hypothesis. Anyone have any questions? And can someone tell me, is this a left tail test, a right tail test, or a two tail test? Anyone? Left tail, right tail, or two tail? So this, because we use less than, is pointing to where? To the left or to the right? This fellow is pointing to the left. So this is a left tilt test, yes. So usually, how do we know what kind of test is? You just need to figure out where does it point to. So you're pointing to the left tilt test. I know the question didn't ask, well, what kind of test is this? But I just want to bring it up so you guys know that this is a left tilt test. All right, we'll repeat again in question 2. This is the claim statement. The claim statement says that the mean pulse rate is pulse rate of adult's meal is equal to 69 beats per minute. Again, for a random sample of 133 adults meal, the mean is this. Now, this is not important to us because we are only writing this in a symbolic form and the noun and the alternative. So the one that I cross out is not important because we're only doing step number 2. However, if we are doing this in the whole during the whole 7 steps, yes, the one that I cross out is important to us. Okay, so but step number 2, we don't care about it. So how do we write this in the symbolic form? Okay, the mean pulse rate adult is equal to, so equal means that equal 69 beats per minute, 69 beats. So symbolic form is really easy. That means that we do not want any words, we just want it in symbol form. So this will be what we call as a symbolic form. Okay. Now you need to write the noun and the alternative, which is H0 and H1. So again, you have to pick either P or mu. Again, P is for percentage or proportion. Mu is for mean. And you can tell this by reading the claim statement, you have the word mean. So we are not doing proportion, we are doing mean. So in order for us to write the null hypothesis, the symbol we use is mu. And don't forget, null hypothesis, the symbol, the equal sign has to be used. And the 69 bits per minute BPM will be used for the claim value. So don't forget, this is your claim value. C value. I just put it down as C value. So you know this is a claim value. And for the alternative, this is something you need to know. So if the claim statement says that this is equal to, your alternative we will pick in this case is gonna be, anyone want to take a guess? Less than, greater than, or not equal to? This is super important. Anyone? Which one are we going to pick? We will be picking the not equal to symbol. So if the question in the claim testing call us to test for equal to, this is a claim that calls to test, make sure that you test not equal to. And don't forget, the claim value is still 69 beats per minute, not 69.6. We don't use this number. Okay, so again, your claim value have to be the same. The mu, we are using the mean here, and then the equal and not equal to in this case. So this is how you write your noun H0 and your alternative H1 statement, hypothesis statements in this case. And can someone tell me, is this a left tail, a two tail, or a right tail test? Anyone? What kind of tail test is this? Is that a left? Is that a right? Or is that a two tail test? So this is called a two tail test because it's not equal to. So if it's a less than, it's called a left tail test. If it's a right, it's greater than, it's a right tail test. If it's a not equal, it's a two tail test. So this is very important, how to write what we call as your noun and your alternative hypothesis. That is actually your second step. Okay. Questions? All right, now we're going to go for third step. Third step is to find the sampling distribution, not the test statistic. It's the sampling distribution. Now, what is a sampling distribution? A sampling distribution, you can either, in this class, it can either be a Z distribution or a T distribution. So you only got two choices here, Z or T, okay? So how do we know we are using a Z sampling distribution if we're doing proportion? So if a question is doing proportion, your sampling distribution is always Z. T distribution is only used when we are talking about mu, which is the mean. Okay. So if I want you to do question 1 in the example, what sampling distribution is this? So the sampling distribution we will be using for question 1 here is going to be a Z distribution. And the reason why this is a Z distribution is because we are doing proportion. You can tell by looking at the P's. Okay. What is the sampling distribution for question 2? Sampling distribution for question 2 in this case is a T distribution because we are doing mean here. Okay, so make sure you guys know this. This is not that difficult. So make sure you read the question really carefully. Are we using a Z sampling distribution or a T sampling distribution? And then the next one we're going to talk about is what we call as the test statistic. Okay. So what is a test statistic? Test statistic is a value used to decide about the null hypothesis testing. This is found by converting the sample statistics to a Z-score or a T-score. Now, you do not need to worry about converting this because StatCrunch will do this for you automatically. But make sure you guys know that proportion, we will use the Z sampling distribution. That's why we call this as your Z-score. And then when you do the mean, we call that as your T-score, assuming that the null hypothesis is true. So what is a test statistic? Okay. Example is, let's say that you have this critical region here, or we call it as this is a significantly high. So how do we know that if your claim is valid or not valid? If your test statistic falls into this non-shading area, then your claim in this case, your H0 in this case will be valid. That means your null hypothesis will be valid or will be true. Or in other words, let me put it down here. Your H0 is true. However, but if your test statistic falls into the shading, the significant high or low area, then your null hypothesis will be false. So this is what, how do you know which is true, which is false? It depends on the test statistic. If your test statistic falls into this area, that means your Z-score or T-score falls into here, your H0 will be true. Okay. However, if your test statistic falls into this area, then, oh, not green because it's a green here. Then your test statistics, your H0 will, your null hypothesis will be false. So this is the importance of test statistic to figure out, are we supporting the null or are we rejecting the null? Okay. Then we have this alpha. So this is step number 3. So step number 4 is where you have to find all this, find the critical region, significant critical value, and p-value. Again, instead, we are going to use StatCrunch to find this kind of values. You do not need to use any tables or formulas because in your homework, if you do happen to solve this or you watch the videos found in your textbook, they will use formulas and tables and so on. So please do not use them. StatCrunch will help you with this. So I will tell you what are the significant level, critical region, and critical value. And then if you have time, we do the p-value. Okay. So what is a significant level? Significant level alpha is what we call as the probability that used as a cutoff to determine when the sample evidence constitutes significant evidence against a null hypothesis. So what is alpha in this case? Alpha, to make it simple or in more easy word, alpha, the significant level, is the opposite of the confidence level. Remember the confidence level that you guys did in chapter 7, where you want to find the 90% or 95%? iPhone, I have no idea who you are. So though this is, you got, please write your name, iPhone. I do not, if I can read your mind, I will tell you who you are, but I have no idea, iPhone. Please write your name. So otherwise I mark you absent, whatever iPhone you are. So significant level alpha is the opposite of confidence level. So that means that if you do a 95% confidence level, then your alpha will be 5%. iPhone, this is your last chance to put whoever you are because this is your second time writing your name. Putting that down, I have no idea who you are. Otherwise, I'll mark you absent in this case. You hear me, iPhone? Are you still there, iPhone? Nope, he or she is not there. So I will mark him absent. That's easy. Who know who his iPhone is? Anyone know whose iPhone 221 is? Don't look at me. I do not know. So I think this person who just came in say present and left. So I will say that. Sorry for that. So the significant level alpha is the opposite of confidence level. So make sure you guys know that. So alpha in this case, if you want to look at this picture, alpha is this. This is alpha. So that means that this is your 5% if you use it. And the whole non-shading area is called a 95%. So this is called a confidence level that we use. The shading area alpha is 5%. So this is what we call as the confidence significant level here. And then critical region or rejection region is the area of all the value of tests that cause to reject the null hypothesis. So what is the critical region or rejection region in a more easy way? This critical region or rejection region is your shading area. Remember when you shade this area on the left side or right side or tilt on two sides, this shading area is what we call as the rejection or critical region. That means that if your test statistic falls into this critical region, you will have to reject the null hypothesis. Okay, so that means your null hypothesis is false. You have to reject it. Okay. And what the last one we're going to talk about here is the critical value. What is the critical value? The critical value is a value that separate the critical critical region from the test statistics that do not lead to rejection of null hypothesis. So what is a critical value? A critical value in this case is the line. This line that you draw here. This is your critical value. So this critical value is to separate between either you reject or you fail to reject, or true or false. Okay. So we found this before in chapter in the first example that we just did just now. Remember this T alpha over 2, Z alpha over 2, that is what we call as your critical value. That is this value that we talk about here. Okay. So, so you know that in critical value, if it's a right tail test, your critical value should be positive because the mean here is 0. That means the critical value should be on the positive side. And for the left tail test, your critical value should be negative. Okay. And for the two tail test, the critical value in this case will be a negative and a positive. So that's why this is what usually the confidence interval you will get, both plus and minus sign, because you will have a two tail test in this case. So make sure the left tail is only negative and the right tail is only positive on the critical value side, and the two tail is plus minus. Okay. We're gonna stop here today, class, and we will continue the rest of this, how you find the critical values in this case, which we already did it on this. If you remember what we did in chapter question 1 just now, the T alpha and Z alpha over 2. So we will bring it up again on tomorrow class. So make sure you guys start working on your homework. Then if you have any questions, please stay back. So that's the end for today's class.